Alright guys, this is unit number 7, and what we're doing is going to combine lesson 1 and 2 into one lesson. So we're going to jam a lot in this, and let's see how we do. So we're going to be adding, subtracting, and multiply things called polynomials, which we have to introduce. So here's what the definition of polynomial expression is. Any expression in this form, and I know this looks complicated, but a is a coefficient, just a number in front of a variable x. So it could be something like down here. See this 4x squared? 4 is the a, and 2 is the n. And then b would just be a different coefficient. So kind of down here you could see that. And then these are descending. So n's bigger than -1, -2, and it keeps going down until you get to a constant. A constant is a number without a variable. So this 1 and this 8, those are constants. And notice that it's saying the exponents, whatever they are, have to all be positive integers. Not all the powers need to be present to be represented, because the coefficients can be 0. So we don't have to go from n to n-1. We could go from n to n-2, because this b could be a 0 and make that go away. So on this first exercise, number 1, it says, of the expressions shown below, circle all of them that represent polynomials. So circle the ones that are polynomials. Discuss why the ones aren't polynomials that fail the definition above. So which ones are and which ones aren't polynomials. So try that now, please. All right, so hopefully you circled this one and this one. These are polynomials because we have coefficients, variables raised to a power. All the powers are positive, so remember that's a power to 1, and technically this is a power 0, which means it goes away. And same thing with this one. Now this one isn't in descending order where this is the highest to the lowest, and we'll talk about that in a minute, but that is important, but you'll see. Now these two in the middle are not polynomials, so this first one here, the reason it's not is because this term right here. Remember, 1 over x is really x to the -1 power, and all the powers have to be positive, so that makes it not a polynomial. And here notice that none of the exponents are going to be actually variables. These n's are representing numbers that are going to be in there. The only variables are these x's on the bottom. So this third one is not a polynomial, because basically the exponents can't be variables like that. That's some type of exponential expression, but it's not considered a polynomial. Alright, so now that we know what a polynomial is, we can start doing some things. First, you need to know how to properly write them in standard form. This is important, and you can lose points on a Regents or a test if you don't put things in standard form. Basically, all you have to do is rewrite the equivalent expression where the powers of the variables always descend. So the biggest exponent first down to the lowest exponent. Also, something important to know is called the degree of a polynomial, and this is really simple. It's just equivalent to the highest powered term of the polynomial. So let me show you this first one, and then you could do the rest. It's pretty simple. So we're going to write each of the following polynomials in standard form and degree and determine its degree. So for part A, all you would do is do something like this. So notice that the highest power is 5 to the third power, so that came first. Then 3x to the second, and then it's -8x, and then it's +7. So this is really power of 3, power of 2, this is a power of 1, and this is a power of 0 or no power. And the highest power is the third, so this is called a third degree polynomial. So now you go ahead and try B and C on your own, and hit pause and only play once you've tried them. Okay, for B, hopefully you got something like that. Hopefully pretty obvious now. Notice that there's no third power, not a big deal. You can skip powers. You could go from the fourth power all the way to the first power. So that would be in standard form. That is a fourth degree polynomial. And part C, again, be careful of the signs. Notice that 5x squared is actually -5x squared, so be careful of that. And that 3 is positive. And this is second power, first power, 0 power, and second degree polynomial. Alright, so now that we know what a polynomial is and how to write them, now we can start doing some operations. So first we're going to take the sum, or add them. And you guys pretty much did this before in 7th grade. We're just going to simply combine like terms. So again, I'll kind of help you out with the first one. And when we do this, we should get something like this. And the reason is we're simply combining these terms because these are like terms, x squared and x squared. However, it's a common mistake to try to do something like this, 7x to the 4th, and add those exponents. But we're not going to add the base numbers, or the coefficients, excuse me, and the exponents. Remember that exponents represent multiply. So when I say x squared, I mean x times x. It's not x plus x would not be x squared. That would simply be 2x's. So again, when you're adding or subtracting, we're only looking at the coefficients, the number out in front. We don't do anything with exponents because, again, exponents mean to multiply, not to add. So very important to remember that. Let's get rid of all this stuff. So hopefully that's pretty simple. You can see I added the x squareds, I added the x's, and I added the constants. There we go. So now you should be able to do B fairly easy. So hit pause and try that now. All right, how did you do? Did you get something like that? Now when I used to teach these, I would just tell students to circle the like terms. So like something like I would circle these and watch the sign, it's important. And then maybe I would put a square around these guys because these are different terms. And then maybe put like a triangle around this one. And you could just visually see the different terms. And now it's simple. 7, -4, and -5 and 9, and 1 and -3, or excuse me, 4 and -3. There you go. Pretty easy. All right, now we have to subtract them. Now these are a little harder. There's just one additional step you have to remember. This is very important. You should have been taught this in 7th grade, that subtraction really means to add the opposite. So when we gave you something like 3 minus -2, you should have learned that this is really 3 plus +2. Exact same concept when we're doing polynomials. So on this first one, this minus sign means we're subtracting all of this. So we have to do minus a -2, which really makes it a +2, minus that x, which makes it a minus x, and minus a -3, making it a +3. So when we do this, it's going to look something like this. Hopefully you can follow. Couple ways to think about it, but basically what's happening is this first polynomial, you don't change anything, and then the subtraction sign becomes a plus. So we're going to add, then everything else becomes the opposite. So -2 becomes +2, positive x becomes x, -3 becomes +3. Think about what we're doing is distributing. We're multiplying a negative times a negative, positive. Negative times positive, negative, and a negative times a negative, positive. Either way, you must remember to do this step here before you start combining like terms. Now that we've gotten rid of that minus sign, now just combine like terms. What they did is they used that commutative property and they kind of just switched things around and then combine like terms. Fairly easy. All right, with B, be careful with this one. It's a little tricky, but basically this minus sign is not just a -2. It's saying minus all of this. Okay, so that's how they intended to write the problem. So now that you know that, go ahead and give B a try now. Okay, how'd you do? So there we go, get that out of the way. And basically notice that they just did 6 minus the +2, or 6 minus 2x squared, and it's 6x squared I should have said. 5 minus -4, so 5 minus -4x is really 5 plus 4, that's where the 9 came from. And then they had to do 3 minus 7 and got the -4. So hopefully that went okay for you. All right, so adding, subtracting, now we're just going to simplify some polynomials and make sure your answer is in standard form when you're done. So try A and B. You should be able to do this now, hopefully. All right, so for problem A, you should have got this as your answer. Basically just combining like terms and putting it in standard form. Fairly easy. B, a little more difficult. You had to deal with that subtraction sign first. So hopefully you added the opposite, and you can see that this becomes a negative, and this becomes a positive. And then once you do that, then you can combine like terms and get your answer. Okay, adding, subtracting down. Now we have to multiply. So with multiplying, basically all we're going to do is learn how to use our exponent rules that we've done and multiply things fairly easy. So you should already know how to do A, B, and C when we did our exponent rules last unit. So give those 3 a try right now. All right, did you come up with these answers? So answer for A, you should have got 10x to the 5th. So now we're just simply doing 5 times 2. And now we're adding exponents since we're technically multiplying. So B, hopefully you got 24x squared. And C, a little more difficult, but you should have been able to pull this out. The final answer, 3/8 x to the 11th, y to the 6th power. So hopefully you did okay with those. Now using that, now we can do a little more complicated stuff. And we're going to use our distributor property. So basically you're taking this and you're just distributing it to those. Same thing here, taking that and distributing it to those. And you're taking this whole thing and distributing it right there. So again, you should be able to do these 3, so give that a try. Hit pause and only hit play once you have answers. All right, for part A, hopefully you got something like 6x squared minus 2, and you can see the work done right here. You don't really have to do all this work if you don't want to, as long as you show some distributing. Question B, again, you should have got 4x to the 4th plus 3x squared. Now don't try to add these last 2, those aren't like terms. This is the 4th power, this is the 2nd power, so you're done right there. And then finally part C, a lot of stuff, but be careful. Just make sure you add the right exponents. Remember this x really is x to the 1st power, so x to the 2nd, x to the 1st makes x to the 3rd down here, so check your answers. Now if you understand that, the next parts won't be too difficult. It's just pretty much more of the same. Now this one down here, some of your high school teachers might refer to this as FOIL, standing for first, outside, inside, last. We don't really teach it like that, but old teachers call it foiling. What you're basically doing is taking each of these terms and distributing it to each of those. So this x has to be multiplied to that and that. Then you have to take this positive 2 and distribute it like this and this here. And again, I'll just show you some work, and then hopefully you can try E on your own. So you can see what they did. Like I said, they took the x and multiplied it by both terms. Then they took the plus 2 and multiplied it by both terms. And then notice when you do that, these middle 2 can actually combine, and that's where that 4 came from. These don't have anything to combine to, so then you just write it in standard form and you're done. So why don't you try E and see how you do? Hit pause if you haven't yet. All right, for E, hopefully you got something like that. Now, again, you don't really have to show this step right here. Most teachers don't require that. Like, you could just go to this step and simply do something like this, write the 15, do this, write that one. So the lines are kind of skip this step right here. Now, F, I think a lot of you, when you try it, are going to get it wrong at first, but I want you to try it and see how you do. So try that now. All right, so how many of you guys wrote this? 4x squared plus 25. If you wrote that, I understand why you wrote that, but technically that, or not technically, that is wrong. Okay? So you have to remember that when we do order of operations, we have to follow proper order of operations. We can't do exponents by distributing that exponent in there before we do the parentheses. So we have to actually square the sum of this, so you have to add those first, which you can't really do. So what you need to do, and be careful, I'll explain this more in class because I'm running out of time, but remember, when you square something, it means you're multiplying it by itself. So this 2x plus 5 times 2x plus 5, that's how you need to write it. Now it's just like question D and E there, okay? So hopefully that makes sense. Look at the work, hit pause because I have to go a little faster. I'm running out of time. This is 2 lessons at once. So on G and H, I'll kind of help you out, but basically you're going to distribute this to all 3 of those. Then you're going to distribute this to those. And on H, you can't do 3 at once, so multiply these 2 first, get something, and then take this and multiply it by that. And this one, there's 3 of them, so be careful. So hit pause, try all 3 of them, and I'll give you the answers. All right, so I don't have a lot of time, so I'm just going to put these up here. There's way more work than you probably need to do, but just kind of look and hopefully you can follow along. And if you're having trouble with this, definitely ask for help in class tomorrow. And we'll see you in class.